So this is our production MongoDB in the cloud talk. I think we promised that we would go from essentials to corner cases. Who are we?
I'm Mike Hobbs. I'm a developer, Python currently, many other languages in the past. I do the app side and some of the DBA side of Mongo administration. Bridget does?
Bridget Krumhout. I'm a sysadmin. I do DevOps. Ooh, exciting. Also at 8th Bridge. And 8th Bridge, we do social commerce. Wow, I cannot talk today. That's the problem. Social commerce and brand interest graph analytics. I got that exactly from our website because, I don't know, we think of it more, on our end, we think of it more as the stuff with Hadoop and the stuff with MongoDB, but apparently that's how we actually sell it to people. Jamie. But anyway, so we're using social graph data to monetize social for our corporate customers.
And one note I'd like to make is that this is more of a, not a 101 class for MongoDB. We kind of assume you've already read the About page on the MongoDB.com site, so it's not gonna, we're not going to spend too much time on introductions of the technology. Why did we as 8th Bridge choose MongoDB instead of all the other NoSQLs or just a standard relational database? The main reason was this cartoon is
I found this online. It's somebody, I guess, drew it on a napkin on an airplane in 2011, possibly kind of dated by now, but still a little funny. And it shows a little bit of what I understand to be the thought process before I joined 8th Bridge. I came in and MongoDB was a fait accompli.
So yeah, we chose Mongo mostly because of the is your data structured box, and our answer there is no. We like to change our data, add new fields, abandon old ones fairly, well, not regularly, but it happens. There's a lot of data schema churn. That was the main reason. Another reason why we chose Mongo instead of, say, a key store type of storage like HBase or Memcached, if you're familiar with that, is because it has a fairly powerful query language beyond just storing key value pairs. You can like reach into actual records and say, give me every record where first name equals whatever. And lastly, the reason why we chose Mongo instead of, say, Riak or other like multi-master type systems is because eventually consistent is kind of hard to program it can be done, but it's kind of like concurrent programming. You just got to be careful, and we don't want to have to be careful.
Because why be cautious, hey? All right, so if you read the blurb in the Exciting Sessions guide, you possibly the blurb that brought you here today, you saw us tease a little bit of what our infrastructure is like. We're not going to go into immense detail about our specific configuration, but there's some numbers that might give you a sense of the scale and make it kind of more interesting.
Yeah, so our biggest database is a 12-node cluster of 4 shards, and each shard is replicated 3 times. Our desired response time for our application is under 10 milliseconds, so that highly limits our tuning. I mean, if you can accept 5-second response times, you're not going to be quite as concerned about I/O weight that we are, for example. Our total data size, well, you can read those numbers. I don't need to read them off for you. You want to talk about EC2 and what the challenges are?
Yeah, so the other half of our title, Production MongoDB, ooh, we didn't just play with it once, in the cloud, which is to say we don't have a data center full of hardware. And when we are worried about the IOPS for our storage, we don't have a procurement process and a bunch of vendors showing us glossy slides about what we're going to do. We're a startup. We use EC2. The instance sizes come with a reasonable amount of memory, depending on how much you're willing to pay, but storage is always kind of a problem because most of the storage is EBS, the elastic block storage, is, what's a good word for it? Slow.
Slow.
And there's certain things you can do to try to make it a little faster. We can talk about what we've done in some cases, but for the most part, we we use EC2 in a way that we replicate, for example, across regions. We replicate our data from the east to the west in order to have disaster recovery. But the way MongoDB works, it's a good idea to keep at least some of your secondaries in the same, at least same region, not necessarily the same availability zone if you know EC2, but at least the same region, because we'll talk a little in a bit about how Mongo handles who's in charge here. And it's not what you would necessarily think, so. Oh yeah, and we also, it's not the only data store we use. Hobbs mentioned HBase before, and we do actually use that. We have some actual relational databases for the analytics work. We have, we use S3. Just throw your data in a big pile of disk. So it depends on the data set. Yep. And we've also, you can kind of talk about how we found that some data sets that we had in Mongo, we realized it wasn't the right place for it.
Yeah, so log journaling, like we do tracking data. We just track who's doing what. That's kind of like write once, read many, but it's a very high, very large data set because it's a lot of transactions at once. We found that just writing those off to a file and then running like a map reduce on them after the fact was good enough for our purposes. We didn't need real time who did that 3 seconds ago. So that was Mongo was falling down horribly with lots of indexes on very large data and trying to keep it all in memory.
Hey, look at that segue. So the biggest challenge that we have found is when Tenjin says, the creators of Mongo says that your working set needs to fit in memory, you should listen to them. They are not kidding. And your working set, yeah, Luke knows. So it's not just your indexes, though that turns out to be the biggest use case for us, but also any frequently accessed records. So basically, do not swap. What does that, ski instructor in South Park say? If you got to swap, you're going to have a bad time. And EBS latency means if you're in the cloud, you should definitely not swap. And you might say, oh, provisioned IOPS, EBS optimized instances. Yes, and yes, they help, sort of, but not enough. So this is just an entertaining graph from New Relic that shows one of our MongoDB servers recently. You can see dates on there. And when the IO wait does that, that's very, very bad. And if your application expects response time of things that are looking at that database in particular, you're going to have problems. So the answer to that is more memory.
More memory. Just a slight digression on memory is fragmentation. It's not talked about much in any of the blogs or articles that you read about MongoDB, but it can be a serious killer if you're running, especially if you're running light on memory. So what happens with fragmentation is large chunks of your data set is actually full of holes, zeros. It's not being used. You don't want that taking up all of your precious memory. For example, here's some actual data. How you can tell if you're fragmented is take a look at your storage size and compare it to your actual data size. And here we can see it's got 22 megabytes of storage size versus actual 5 megabytes. It's highly fragmented, 4x, 5x, however you count it. In this case, it's only 5 megabytes, so it's not really chewing up a whole lot of memory, but it's an example. And down here is an example of a padded insert that you can use to prevent both fragmentation and high I/O. If you create a record or a document in MongoDB terms, and then you have to update it so it grows larger than it was previously allocated, it's got to read that record out, move it to the end of the line, and hopefully fill up that hole with another record sometime in the future. If you use padding on your initial insert, like I showed there, it pre-allocates the whole record for you, so when you come back later and do the update to actually provide the actual detail of the document, it doesn't have to move at all. It's all kind of in place in update.
Yeah. Grout remover, love it. Okay, yes, Jamie, it was bugging me, so I did go and redact the names of the servers. And I don't know why. We're in EC2. We have security groups set up such that even if you could see the name of the server, you couldn't get to it. But whatever, paranoia, sysadmin, professionally paranoid. So this is an example of one of the web interfaces you can, and it's a little chopped up because it actually is all on one line, but I wanted to make it actually readable. To look at a replica set, one of the things that's pretty useful in Mongo that you definitely want to use, in our opinion, is the replication. It's possible to run in a standalone mode, but using replication means that you get not only the disaster recovery, the failover, and to a certain extent, more availability, depending on whether or not your queries are slave okay. You can set some queries to just talk to secondaries. But this is kind of an entertaining example because this is right after, I'm looking at me would be a secondary, right after I replaced a primary, so that's why it's only been up for a short amount of time. And you can see here in this view, the most important thing that makes replication work is the op log. So basically, all of the secondaries just take the operations from the primary and just run them until they're up to date. This secondary actually thinks it's a little ahead of the primary, but that's kind of an artifact of, syncing. Those op times, they're in hex. If you go out on an app on your phone and check, they don't actually match this. I went and captured that at a slightly different time because I realized it would be interesting to show you that in a different view well, you can see it in the log files, but also in a different view in the web interface to Mongo. It just answers on a port with some useful stuff. You can actually see what op time your servers are at. So if you have one that's lagging, you can actually see how long it's probably going to take to catch up. So you can make strategic decisions about whether or not you should make any changes to those particular machines. Let's see, what else should we say about replication? Oh, okay, so you see that one has promoted itself back to primary. It did that without any intervention from us. And we can probably look at the next slide to see why. Everything is done by elections. So if you've read anything about replica sets in Mongo, you're like, yeah, okay, that's pretty obvious. Yeah, there's a few caveats that maybe aren't as clear. Like Tengen says a bunch of stuff about the recommended, strongly recommended number of voting members of a replica set and that sort of thing. You should definitely not run a 2-member replica set without an arbiter as a third vote. Because if you do, and then you say this is just like a test cluster, and then you take the secondary down, the primary will demote itself to secondary. That's what it'll say in the log file, and you'll say, what? And then your staging infrastructure will be down until you fix that. So don't be me, don't do that. Actually, I was pretty sure it was going to do that, but it was okay. Staging could be down right then. I just wanted to see if it would, and it did. If you can't, I think Tengen sees this as a feature because if you can't get a quorum of your replica set members, that maybe means you're isolated in a network way. Well, again, in EC2, that could happen, but that's not usually what happens for us. But just keep in mind that you definitely want to make sure that there's always going to be an odd number of voting members. They don't have to be data-having members. They could be arbiters, but an odd number of voting members. And if we can just go back one slide really quick so I can point out the priority number. You set priorities on your servers, and that helps you rig elections. So that one, the third server is in US West 1, and we don't ever want that being primary. So it has a priority of 0, so it can never win an election. And that other secondary can win, but the one we want to be primary has 2 points, so it will almost certainly win every time. Okay, moving forward. Yeah, so say you want to actually manually change the primary because, say, you want to upgrade MongoDB, among other things, or quickly make your instance have twice as much RAM. There is no become primary command, which was a little bit of a surprise to me. When you do a manual step down, well, how did you describe it, Hobbs?
Essentially, when you want to change your primary, you simulate a server failure on your primary and let the mechanisms for resolving all the resulting chaos sort itself out and have your secondary become primary after the fact, after a few rounds of voting and whatnot.
Yeah. So all those things that look like errors, they are. Those are errors being thrown to your application. You'll have to handle those. So, and then you will see your, if you have a server that's coming up, you will see it in different states, and a server that's in down initializing, it's not really down, it's just not caught up. And startup 2, they can't even be secondaries. So, but it will eventually, hopefully, if you have a server that can become a primary right away, it will take maybe 30 seconds, but that's a long time to have operation failures in your application. Yes. Yes. Not about the election specifically, but about the operation failures and auto reconnects. I'm glad you asked because that is actually one of the exciting things that we're going to talk about. Oh, wait,
No,
this
no,
is,
no.
oh yeah, no, go ahead to the next slide,
All right.
that's fine. Oh, this is actually not that one. This is a little bit of a digression before we get to sharding, but this is an interesting bug that Hobbs opened with Tengen. I don't know if you want to describe a little of what happened here.
I can't vouch that this happens every time, but we had a one replica set in a single sharded environment, and we said, well, we want to turn on replication so we can migrate our data to a larger instance or a smaller instance. I don't remember the circumstances, but we wanted to migrate to a different server. I turned on replication, migrated everything over. I said, okay, now that we have this server that we want, let's turn off replication so we don't need to bother with it anymore. Can't disable replication in that scenario. It says I'm
Trapdoor
replicated.
function.
Yeah. There are ways of getting around it. Pretty much dumping your data and reloading it into a fresh instance would have done it, but it was a complicated, hopeless mess that we ran into.
Because it can't do updated existing anymore. Kind of important. So, all right. So sharding. This sharding decisions were made before I got to 8th Bridge, and they definitely thought about them for at least 15 seconds.
Yeah, so the promise of sharding is that you can divvy up your queries and your inserts and your updates across multiple servers so that you can parallelize CPU usage, I/O across multiple servers, multiple disks. That's the promise. Our experience, however, is that because MongoDB values memory so highly, instead of creating 2 servers and sharding across 2 servers, it was a whole lot more effective just to double the memory in our single server, and that just dropped the I/O weight and our disk usage down to almost 0 because it was able to store pretty much everything in memory that it needed to, its working set. So think twice before you start sharding. Try more memory first is my recommendation.
But if you're going to shard, don't wait too long.
Yeah, that's the bottom point there is if your one collection gets above 256 gigabytes, sharding is no longer an option. It can't start at that size.
And they have raised that limit over time, and there's currently a JIRA issue of Tengens where they say it's now 512, and then another Tengen person says, well, let's not update the documentation to that, because 256 is a safe thing to promise. So.
Yeah, one misconception sometimes is that sharding provides you with reliability, availability. It does not do that. It provides performance. It's a different dimension to do. And carefully choose a sharding key, because once you've sharded on a key, you can't go back and change it. They've made, and sharding on an object ID is a very bad value, since all new inserts will go to a single server and pretty much flood it with hot updates. Version 2.4 has come out with hashed shard keys, which mitigates that a lot. So newer versions of Mongo will not have that issue as badly. And one thing about sharding key is it kind of goes against what we wanted in Mongo in the first place, is a dynamic reconfigurable schema. Once you pick a shard key, you can't change your schema. You're stuck with having that key in pretty much every single record you have, and it's immutable.
So sharding is considered to be some great thing that you want MongoDB for, or NoSQL for, whatever, but just be aware of these things before you choose it.
Oh, and the way that data actually gets sharded is there's 2 mechanisms involved. One is splitting, where new inserts go to several different shards in your cluster. However, also existing data can get migrated from one shard to another in order to rebalance your data across the entire cluster. Things to be aware of, this may not be a generally big concern against everyone who uses MongoDB, but in our case, we want response times less than 10 milliseconds. So the delay that happens after a chunk is moved from one shard to another during that handshake, all queries block for, gosh, almost 100 milliseconds. So it's death to us. But be aware of that. And if you're running low on memory and you're trying to shard and get get data off of your overloaded server, you're going to have problems, because as soon as that data is moved, your server is going to try to do a bulk update of all of its indexes. The indexes are more than likely not in memory. It's going to have to page to do that massive index update, and you're just going to bring everything down. We've seen 10-hour slowdowns because it's trying to update large amounts of index data.
So you do have to balance if you're sharding, but I mean, if you don't, you're going to end up with a lot of hot spots, but it's best run off peak.
Yeah, and this is an example of our balancer configuration. You can configure the balancer to say start at 11 o'clock at night and stop at 6 o'clock in the morning, and then it does not move any data after that period.
Oh, do we want to talk at all about the slight amount of complexity that sharding introduces in terms of the
yes.
config?
The graph here, if you want to talk about it.
Just keep in mind that if you do decide to shard, you can no longer talk directly to your replica sets. You have to talk to something called MongoS, a shard handler. That's a daemon that you can run, say, on your application servers. You can have a dedicated server for it. We have both for different needs. And you also do need to maintain a separate, probably 3-member replica set of, well, it's not exactly a replica set, but you need at least several config servers that handle the sharding metadata. So you do increase your server load and complexity slightly if you decide to shard. And this is an example of one of the things that happens. We had a question before about how you handle these failures, and have we talked to Tenjin about these? And we have, and the biggest place where we would see these failures after an election is we would see auto reconnects and operation failures. Their high availability documentation talks about auto reconnects, does not mention operation failures as something that you should be expecting. However, Tenjin tells us that it is, in fact, something we should be expecting. And MongoS also has a very tricky thing that it took them a while to work out and give us the information that was helpful to us on. They worked hard on getting us information on that. And basically, MongoS maintains a connection pool, much like any MongoD, and it checks it lazily. And if you have an awful lot of connections in your pool, you could step the primary down and then days later have failures trying to talk to the old IP address of something that's gone. So, and especially in EC2, considering that the IP address does not belong to you anymore, probably, and who knows what could be up on it. I mean, security groups would prevent anything really bad happening there, but it's still odd. So the conpool sync is a very interesting command. It's listed on Tenjin's documentation as conpool sync. Conpool sync is an internal command. Yes, many commands are. It is a very helpful command. It actually clears the connection pool. Well, at least one of the connection pools. We found it helps with with auto reconnects. It does not solve all operation failures. You can also flush the which config is it?
The routing config that the MongoS caches the routing configs to say what chunk lives on which shard, caches that in memory and only fetches it periodically from the config servers, and you can flush that with a command.
Yeah. I have also found on the MongoDB Jira that I spend a lot of time digging around in there looking for answers. And I've also found that conpool sync maybe clears one connection pool, but there may be other connection pools that it doesn't touch, and that may or may not be a bug. It's something that Tenjin's discussing amongst themselves.
And here's some sample Python code to handle such auto reconnects. If you're doing an update that can be repeated over and over and over again until it succeeds, you can use code like this to do it automatically for you.
Because if you get an auto reconnect, you don't know if it succeeded or not.
Yeah, you don't know if
it succeeded. You have to check that externally.
This has a timeout of 10 seconds after 100 tries with a 10 millisecond pause in between. But if you're trying to increment a counter, for example, or you're calculating stats or whatever, and it fails, you don't necessarily want to automatically repeat that increment because you might wind up incrementing twice or up to 100 times potentially before you get a timeout. So in those cases, you pretty much have to back all the way out, check your data, and maybe go back and do it a bulk. I don't know how you would, it all depends. We typically don't use increment operations too often. We pretty much manually update data records with explicit data, so it's not that big of an issue for us, but can be for others.
And you might ask, with these kind of issues, why would you ever step a primary down, have a maintenance window? Well, having a maintenance window is realistic in some environments. not a frequent thing in other environments. And also, if you want to upgrade MongoDB or the compaction that Hobbs talked about earlier, yeah, compaction is a blocking operation. You do it on your secondaries, then you trigger an election, and then you do it on your primary. You don't repair database or compact on a live database, unless you want it to be unavailable, which So MMS is actually pretty cool. Even if you don't pay for 10gens commercial support, you do get MMS. You should probably consider using it if you aren't using it, because you run their agent, they collect tons of data from your Mongo servers, and you can then either go view the graphs that you never thought you would care about until you do care about them, or you can actually, digging around in there, I found you can actually alert on a lot of these things. You could, for mins or maxes. So if you want to be emailed or SMS'd if your number of updates per time increment goes below a certain amount, you could. And yeah, their commercial support actually does rely on this. So if you're going to get commercial support, you will need to run this so that you can give them the data they need to help you.
Here's some tips and tricks that I've put in the slides. One thing that MMS does not tell you is what type of queries are causing your slowdown. It's very opaque. It's just a 10,000-foot view. It's not an individual query view. This is some tips some things you can do to find out. One is using current op and looking at the num yields that each currently executing operation has accumulated. High num yields means a very bad query. It's taking a lot of resources away from other queries that are trying to execute. So here's a way you can tee your Mongo sessions into a log file and then grep for num yields into that log file to quickly get a count to find out which operations are yielding a lot. And if your server is completely unresponsive because something's gone completely wrong, you're hitting it with really bad queries, you can always go in and kill it, and that'll free up your database to be responsive after a while.
And again, your mileage may vary. If that query is precious to you, come up with some other way to save whatever it was doing externally. This just kills it.
Yep. Another way you can optimize or find out bad queries is to look at n scanned. That's the number of records that were scanned in order to fulfill your query. It essentially tells you how well indexed your query, how well your query uses an index. If it using an index very well, you're only going to scan one record, the record you want, and it's there. If you're doing a full table scan, n scan will go up to 10,000, 100,000, however big your table is. So you want to look for queries that are, in this particular example, I'm looking for queries that are using more than double-digit n scanned values, more than 9. Sometimes you're looking for 9 records or 10, 20 records at once, so it's not 100%, but it's a good indicator of where your bad queries are coming from. There's also a set profiling level command that Mongo provides where you can pretty much record every single query that gets executed on the server. There's a bit of a performance impact running that 24/7, so we don't turn it on typically, but it's another way to record your data, and then you got a little kind of a Mongo query there to do the same type of lookup of where your bad queries are that are taking more than 10 and scanned per query.
Right. Another thing you can do is with your favorite monitoring tool of choice. If you have Nagios, for example, is what we're using, but you could do this probably with anything you wanted to. Is we use a plugin. It's available on GitHub. It's reasonably decent. It uses PyMongo. It's the same Python library that our code is using, so we can check a lot of the same things. If you are using Nagios for this, you probably would assume this is the case, but definitely set up service groups because for your Mongo stuff, because it's going to be, otherwise it's going to be an awful lot of copy pasta. And some of the things we're checking, we've recently started checking some different things that we weren't checking before. Some of these, I'm not sure that index miss ratio check, for example, actually works.
Seems to always be 0. I'm not quite sure. I mean, we know for sure that we're missing indexes, but index hits, but it's always come back 0, so I'm not confident with that value.
So if somebody wants to, in their copious free time, fix that, send a pull request to that guy, that would be super. But the main problems we end up having with Mongo are I/O wait. It's nice to get a canary that tells us when some I/O wait is going to happen. If we start seeing our write locks go up, if our flush times start being, in the metaphorical toilet, we can tell that the server is probably experiencing some issues. We can take a look at it. Maybe it needs more RAM. That's usually the answer. Maybe it has a bad EBS volume. I mean, those things can happen. Oh, didn't even talk about that. We're using a RAID 10 configuration. It's kind of the Foursquare special if you've read their blog posts about how they get around slow EBS, which is basically just mirroring lots of it so that we can try to use as many IOPS as possible off the slower disk. And sometimes you get a bad disk in there. What's something else in here that's interesting? So we had a server misbehave Thursday, I think it was, and that wasn't awesome, and it did require some intervention to fix, but more RAM, shocker. But this gives an example of what it can look like when you start seeing slowdowns. The replication lag is an important thing to pay attention to because remember with the whole election thing, you definitely don't want your secondary that's in the region where you would really like it to take over as primary. You go to trigger a step down and then you realize that secondary is weeks behind. How did that happen? How did we not know? Now we will know. That will never happen again. And let's see. Oh, also, remember the priorities we talked about. If you don't set priorities, because you just have some cluster you were trying some stuff on, and it's semi-production-y, whatever, and you could end up with an election happening without you knowing, and then something, say, your tertiary server in the West being primary that you didn't even realize happened until you go look at it and say, huh, when did you become primary? That will never happen again either, because now if primary changes, we will know. So that's the kind of thing you might want to, if you run Mongo in production, you might want to be able to keep an eye on this kind of thing.
Some of our thoughts about where we will be going in the future with our Mongo deployment. Right now, we're already kind of resolved issue number one is doing the better auto reconnecting. And right now, previously we'd only did it on one of our web apps. We were doing it pretty much across the board now for every single, anything that touches Mongo is going to be handling auto reconnects and retrying on an exception. Another concept that when you get a high I/O instance from Amazon, it gives you an SSD disk, but the SSD disk is on its local, what's called the ephemeral drive, which means it's a data that will go away if you ever stop the instance and restart it again. You can use the SSD disk as long as you're using replication. Replication will kind of guarantee that the data persists even if you shut down one of your servers. That's a thought for the future.
If they would only offer SSDs that are big enough for our biggest data sets.
Profiling, oh yeah, like I said, set profiling level has overhead. There are ways to say only profile queries that take more than 100 milliseconds, only take up more than 1 second. There's ways of tuning that. We haven't looked into done that yet. We could probably start doing that and being more intelligent about profiling our bad queries.
Oh, we do plan on adding more alerting on the really specific stuff that MMS can give us. Just, again, keeping a better eye on things so we can get out ahead of problems.
And we're still on Mongo 2.2. 2.4 came out fairly recently.
No, we're on 2.3. We're on 2.3.3 or 2.3.4, depending on the server.
Okay. But it's got some features that we would have liked a year or two ago. It's finally here. We've worked around it since, so they're not terribly important to us now. But if you're starting out on Mongo, they're nice features to have. Make sure you get the 2.4. Wait for the 2.42 because the 0.1 is still a 0.0 release. Yeah,
2.4.0 came out, and if any of you were paying attention, you probably saw that 2.4.1 came out like 3 days later. So we're kind of considering 2.4.1 a little experimental, so we'll probably wait for 2.4.2 at this point, and then do all of the trigger an election, upgrade your secondaries, trigger an election, get your primaries going, that sort of thing. Generally, 10gen will let you know if it's, you can look at their docs, but I think in this case, it's same as before. You can run different members of the replica set or even Mongo S's from different versions. Like they generally are compatible. Always good to check, but they're generally compatible. Questions? Yeah, thank you. Questions, comments? Yes. I'm sorry, I couldn't hear that. We have. It helps to a certain extent only in that you get more IOPS than you would get from a single disk. EBS optimized instances help to another certain extent in that on a typical instance, you're going out the same virtual NIC for your actual traffic and for your connection to the storage. An EBS optimized instance gives you a NIC, well, you and everyone else in your multi-tenancy environment, a NIC that's directly connected for some values of directly and some values of connected to, you've tried this, to your volumes. So, and provisioned IOPS, we've just started to look at, but the bang for the buck isn't necessarily there in that memory tends to be more a problem. If we can just avoid going to disk entirely, it helps a little more. Do you want to talk a little more about the rating specifically?
Yeah, we have RAID 10 going, 4 stripes, so we can try to get as much as a 4x improvement. Typically, we find that we probably run into network congestion on the card before we overload the I/O of a specific EBS volume. We're also using mirroring, so it's a RAID 10 configuration, so each stripe is mirrored, so we can swap in and out EBS volumes if we detect one of them is performing poorly for us.
Oh, and an important thing to keep in mind, an important note about provisioned IOPS that I didn't actually see in their documentation, but when we tested, just a simple DD revealed the fact that, yeah, you don't burst above what you provisioned. So, yeah, so don't think that if you go and shell out for the provisioned IOPS that your performance will be better. In some cases, it could be worse.
You definitely have to shell out like 1,000.
Well, at least. I mean, our RAID configurations are easily bursting at 1,500 regularly, so.
The other thing that we found with rating is that it takes forever because they have to sync. And so you just turn on provision IOPS and like stop rating.
Yeah. I mean, the thing is, if you, we just keep looking at the ones with the SSDs and thinking that'll just solve all our problems. Well, except that the SSDs aren't quite big enough for some of the data sets. So maybe if Amazon catches up on that. Anyone else? Yes, but that's what Chef is for. So, I mean, hopefully your process will be really fast. Actually, we have an even faster process that I believe Hobbs devised. You want to talk about the really fast way to just grab the volumes and stick them on the other?
Oh yeah, so you just detach your EBS volumes, reattach them to your new instance, and you don't have to migrate data or anything like that. You just gotta, and we use Chef regularly for every single one of our servers, so it's not a big deal to bring up a new one. It's pretty much automatic. Yeah, you can't buy memory without CPU, so yeah. No.
Yeah, it's very much like how you all have like a zillion minutes in your calling plan, and you're like, I would prefer less minutes in my calling plan, more data. Yeah, you can't get more memory without more CPUs. All right, I think we're probably out of time. Thank you guys for coming.
Yep.